Welcome to our video tutorial here on identifying equations for graphs of exponential functions. Specifically, what we're going to do is take the graph of a particular exponential function that we're provided and write its formula in terms of a specific exponential function. So the graph that we see on the screen, we want to write its equation in terms of y equals 7 to the x. The first thing that's probably worth considering is what does the basic shape, or the parent graph, of y equals 7 to the x look like? We're going to take just a second and put it on the screen over here. The parent graph of y equals 7 to the x, and all exponential functions, graph through the point 0, 1 as their parent graph. Then, when we plug in x equals 1, we get a y output of 7. Now, looking at this graph and looking at the picture we ended up with, what happened? Well, one thing is that we certainly reflected this across the x-axis. So when we list off the transformations, we definitely reflect it across the x-axis. In the parent graph, the distance, vertically speaking, between those 2 points is 6. In this graph that we're provided, the distance, vertically speaking, between 10 and -14 is 24. What did we do to go from 6 to 24? Well, we vertically stretched by 4. 6 times 4 is 24. Please keep in mind that that works because, well, we're 1 from 0 to 1, and we're also 1 away to go from 4 to 5. When we're giving these graphs, as we indicated in class, those points would be based on the 2 key points from the graph of the basic shape. Next up, we have our reflect across x, we have the vertical stretch. What happened specifically to this point right here? 0, 1 became 4, 10. Reflect the point 0, 1 over the x-axis, it's going to end up at 0, -1. And we're vertically stretching it by 4, so it's going to end up at 0, -4. How do we get from that spot to where the point closer to the asymptote ends up at 4, 10? Well, on this one, we're going to have to move it to the right 4. That goes from 0 to 4. And we're going to have to move it up 14 as well. So when we write out the final equation for this graph, it would be y is equal to a -4, because of reflect across the x and a vertical stretch of 4, times 7, all raised to the x minus 4, that would be the move it right 4, and then plus 14. This equation right here would be the end equation for this graph in terms of y equals 7 to the x. We are going to look at and consider one more example, which is now pictured on the screen. In terms of y equals 5 to the x, what would the equation be for this graph? Again, first thing that we probably want or need to do is picture the parent function of y equals 5 to the x. And it is now pictured on our screen. Like all parent functions of exponential functions, it goes through the point 0, 1, and when we plug in x equals 1, we get 1, 5 on that graph as well. Now in this case, we're reflecting it across the x-axis, and then we are also reflecting it across the y-axis. So we have 2 reflections on this. We have a reflected across x, and we have a reflected across y. What about a vertical stretch? So in the parent graph, it's a 4 span from a vertical perspective. And on this graph, it spans 12 from a vertical perspective. So we have a vertical stretch of 3. 4 times 3 is 12. Again, that happens and that works because we're taking those points, those 2 key points, and that's what we're giving on this new graph. Then we always want to look at what happens, or typically we want to look at what happens at the point closer to the asymptote. So once we take the point 0, 1, reflect it across the x-axis and vertically stretch it by 3, it's going to end up at 0, comma, negative 3. Reflecting across the y-axis has no bearing on that point. So how do we go from 0, negative 3 to negative 2, positive 3? Well, we have to move it to the left 2, and then we have to move up 6. So our final equation is going to look like y is equal to a negative 3 times 5, which was our base, raised to the negative, because of the reflect across y, quantity x plus 2. Be careful, you need that quantity there. Otherwise, you wouldn't be reflecting and then moving it left 2. And then we have plus 6. This would be our final equation for this particular graph. Keeping in mind, reflect across the x-axis, vertically stretch it by 3, reflect it across the y-axis, move it left 2, and then move it up 6. So if you kind of keep the parent graph nearby and handy and analyze accordingly, hopefully these exponential graphs, identifying them, won't be that bad.